Welcome to our presentation on the food webs, which was presented by Prasanta Kavanda, Tumea Naidu, Dia Mahapia, and myself, Sanam Webb. Our presentation focuses on food webs, which is a critical topic to teach in the Natural Science and Technology curriculum, which also aligns with the Curriculum and Assessment Policy Statement, which is also known as the CAPS document. The reason why we chose to do this model is because it will fit as a good investigative model for the learners to foster their critical thinking, as well as make it much more accessible for the concepts that are shown in this model. They will be able to look at the model and see for themselves what exactly a food web is.
The investigative problem that learners can look into is what would happen when the secondary predator, such as the hawk, is removed from the food web. Therefore, the answer would be that smaller prey animals and herbivores would often increase in number. With regards to how the CAPS document objectives would be aligned to the model created based on ecosystems and food webs for the learners would be: by the end of the lesson, learners would be able to identify living and non-living things in the ecosystem. Learners would be able to interpret how plants and animals are connected to their feeding relationships. Learners would be able to understand how producers, such as the wildflowers and the grass, produces food for themselves and for other animals. Learners would be able to identify how animals such as the hawk, rabbit, snake, and mouse are either herbivores, carnivores, or omnivores.
Here's how this model can benefit the lesson. Promotes active learning. By having students investigate real-life examples of food webs, they become active participants in their own learning. Observing organisms in their schoolyard, for instance, allows students to see first-hand roles each organism plays, which deepens understanding beyond theoretical knowledge. Develops scientific inquiry skills. This model encourages students to ask questions, make observations, form hypotheses, and conduct research. Investigate different organisms and how they fit into the food web, enhancing their scientific thinking.
The difference between a food chain and a food web. A food chain is a linear sequence that shows how energy and nutrition pass on from one organism to another in a straight line, representing a single pathway of feeding relationships. It typically includes a limited number of organisms and consists of a series of trophic levels. Producers, for example plants, are eaten by primary consumers who are herbivores, and they are eaten by the secondary consumers, which are carnivores, and finally the carnivores or the secondary consumers are eaten by the tertiary consumers, who are the top predators. Simply put, food chains are simpler and easier to understand because they depict only one pathway of energy flow and feeding relationships. An example of a classic food chain could be: the grass is eaten by the rabbit and the rabbit is eaten by a fox. Now, the food web. A food web is a more complex network that illustrates how various food chains in an ecosystem are interconnected, showing multiple pathways of energy flow and feeding relationships among organisms. Food webs include many organisms at various trophic levels and represent a diversity of interactions within an ecosystem, accounting for the fact that many animals eat more than one type of food and have multiple predators. The complexity. The food webs are more complex and realistic because they capture the multitude of feeding relationships in an ecosystem, reflecting the interdependence of different species. An example of a food web could be The grass is eaten by the rabbit, and the rabbit is eaten by a fox, which is a food chain. And then you get another food chain if the grass is eaten by the mouse, and the mouse is eaten by the snake, and the snake is eaten by a hawk. And then you get another pathway if the rabbit is just directly eaten by the hawk.
When we look at how our model works, we look at how this food web includes flowers, a mouse, a hawk, a snake, and a rabbit. Each organism has a unique role in the ecosystem, representing different trophic levels. Here's how each part works and how they connect through energy transfer. But first, let's go through our definitions. What is a food chain? A food chain is a linear sequence that shows how energy and nutrients are passed from one organism to another. Each level in a food chain represents a different role and a different role or a trophic level in the ecosystem. What is our primary, secondary, and tertiary consumers? What are those? Our primary consumer is those who are herbivores that consume produces such as plants to obtain energy. What is our secondary consumers? These are carnivores, or they can also be omnivores that eat primary consumers. And our tertiary consumers, these are typically the top predators eating the secondary consumers.
My name is Dia, and I made the flowers.
The mouse. The mouse acts as a primary consumer because it eats plants like flowers to gain energy. It can also be a food source for the secondary consumers like the snake.
My name is Prasanta Gavanda, and I created a tertiary consumer, which is called the hawk, and a producer, which is called the grass.
Good day, my name is Mia and I made the snake and rabbit. I also made labels for the animals which match the pyramid to identify which trophic levels the animals are in. For example, the snake has a yellow label which indicates that it is a secondary consumer.
The purpose of the arrows in our food web. In a food web, arrows indicate the flow of energy and nutrients between organisms, pointing from organism between eating to the one that consumes it. For example, an energy from a plant to the rabbit shows the rabbit gets energy by eating the plant. The arrows illustrate the feeding relationships within the ecosystem, helping us understand who depends on whom for energy. By following the arrows, we can trace how energy moves through different levels, from producers like the plants to primary consumers like the herbivores, and on to the higher level predators. This shows the connection of all organisms within a food web and highlights how energy circulates to support life in the ecosystem.
Conclusion, our investigative model for exploring food webs provides an engaging practical approach to understanding ecosystems, aligning seamlessly with CAP's objectives. By examining real-world examples, students actively participate in learning, developing skills in scientific insight while deepening their understanding of energy transfer, biodiversity, and ecological balance. This model will not only support CAP's goals, but also instill a sense of environmental responsibility as students connect the lesson to their local surroundings.
We hope this presentation highlights the value of a hands-on, inquiry-based approach in teaching food webs, enhancing student engagement and comprehension of these essential ecological concepts.